The idea of a flat Earth is not new. It predates modern astronomy and has its roots in ancient civilizations who lacked the tools to observe the Earth from space. Imagine a time before telescopes, satellites, or even airplanes. People experienced the Earth as a flat plane, with the sky arching overhead. It was a sensible conclusion based on their limited perspective. The flat Earth theory, however, did not disappear with scientific advancements. It saw a resurgence in the 19th century and has gained renewed traction in recent years, fueled by online communities and social media platforms. This modern iteration often depicts Earth as a disk with a dome-like firmament overhead, encasing the sun, moon, and stars. The resurgence of this antiquated belief, despite overwhelming scientific evidence to the contrary, underscores a crucial point. It highlights the importance of scientific literacy and the need for critical thinking in navigating the vast sea of information available today. The evidence for a spherical Earth is not merely a collection of theories. It is woven into the fabric of our observations, from the ground up to the celestial tapestry above. One of the earliest and most elegant demonstrations came from the ancient Greek scholar Eratosthenes. By comparing the lengths of shadows cast at different latitudes, he calculated the Earth's circumference with remarkable accuracy. Another compelling piece of evidence comes from lunar eclipses. During a lunar eclipse, the Earth passes between the Sun and the Moon, casting its shadow on the lunar surface. The shape of this shadow is always round, a phenomenon that can only occur if the Earth itself is a sphere. Further proof lies in the very nature of celestial navigation. Sailors have relied on the curvature of the Earth for centuries. When a ship disappears over the horizon, the hull vanishes first, followed by the mast. This gradual disappearance is a direct consequence of the Earth's curved surface. Proponents of the flat Earth theory often cite specific observations to support their claims. They argue, for instance, that we do not feel the Earth spinning or see the curvature with our own eyes. However, these arguments stem from a misunderstanding of the scales involved. The Earth rotates at a constant speed, completing one rotation every 24 hours. This rotation is imperceptible to us because we are moving along with it. Similarly, the curvature of the Earth is not readily apparent from the ground due to its sheer size. The Earth's circumference is so vast that the curvature only becomes noticeable from high altitudes or from space. Another common claim is that photographs of Earth from space are faked or manipulated. This assertion disregards the vast amount of photographic and video evidence collected by independent space agencies and private organizations worldwide. The sheer volume of data, coupled with the rigorous scientific scrutiny it undergoes, makes it highly improbable that such a conspiracy could be maintained. Section 4. The pull of gravity more than just a theory. Gravity, the force that keeps our feet planted on the ground, provides further evidence for a spherical Earth. According to the laws of physics, gravity pulls all objects towards the center of mass. For a spherical Earth, this means that gravity pulls equally from all directions, resulting in a uniform gravitational field. If the Earth were flat, as some proponents suggest, gravity would pull objects towards the center of the disk. This would have some peculiar consequences. For instance, the further you moved away from the center, the more slanted the gravitational pull would be. This would make walking a challenge, to say the least. Furthermore, the existence of different time zones across the globe provides another piece of evidence that contradicts the flat Earth model. On a flat Earth with the sun hovering above, everyone would experience daylight and darkness simultaneously. However, we know that this is not the case. The rotation of a spherical Earth, combined with the sun's position, creates distinct time zones, with day and night occurring at different times in different locations. Section 5. Science as our guide, embracing critical thinking. The persistence of the flat Earth theory, despite centuries of scientific progress, highlights the importance of critical thinking and scientific literacy. In an age where misinformation can spread rapidly, it is crucial to approach information with a healthy dose of skepticism, to question what we read and hear, and to seek out reliable sources of information. Science is not about blindly accepting facts. It is a process of inquiry, of testing hypotheses, and of refining our understanding of the natural world based on evidence. Embracing scientific thinking does not require a PhD in astrophysics. It simply requires curiosity, a willingness to learn, and the ability to distinguish between credible sources and unsubstantiated claims. The next time you encounter someone who believes the Earth is flat, engage them in a respectful conversation. Ask them about their beliefs and encourage them to consider alternative perspectives. Present them with the overwhelming scientific evidence and encourage them to embrace the wonders of our spherical planet, a pale blue dot adrift in the vast cosmic ocean.